Okay, we are going now to solve problems for chapter 5 for the study guide, for the study plan. The first problem says there is the guy is pulling with a force F. Let's go to draw the force F. This for F, okay. Or this for F, or this for F. Okay, so let's go to do, and we say, if the weight of this piano is 1,000 newtons, what is the force that the guy is pulling? The guy is pulling, this is the force that the guy is pulling. What is F? So this is the piano. So imagine this is the piano. Over the piano there is a force going downwards, that is the weight. mg, the total force, let's say 100 newtons, no, 100 is the mass. So the force that is going downwards is the weight. The mass is 100 kilograms, so the weight is 100 by 10, is 1,000 newtons going downwards. So you imagine that the piano is the system with the pulley. The pulley and the piano, the mass is 100 kilograms of the pulley and the piano. So what happened? If there is 1,000 newtons going downwards, it means that there is 1,000 newtons going upward. And the 1,000 newtons should be 500 plus 500 going up. And this is in equilibrium because the sum of all the forces is 0. So the force that the person is doing is 500 newtons. And the problem is solved. Let's go to the next one. The next one say like this. There is a mass of 6 kilograms. There is a mass of 6 kilograms. This is the tension here. There is the weight. And he said there is an additional force. With this additional force, the mass that is here, is at equilibrium, is an equilibrium. So over the mass there are 3 forces, or 4 forces. 1, 2, the weight, and the external force. And the external force say that is 410 newtons. And it says that the system is in equilibrium, so the acceleration is 0. So the object is not accelerating upward, it's not accelerating downwards, it's just acceleration 0 of velocity constant, or if the constant of the velocity is the 0 velocity, velocity is 0, it's the same thing. So what are the Newton's equations? The sum of all the forces are 0. What are the sum of all the forces? Forces going downwards. Let's go to put it like positive. Here it doesn't matter if you put it positive or negative what is going downwards because there is an equilibrium. So let's say that the weight is positive, mg. The external force, he say the problem that is going downwards, so we put it positive. Now there is t cosine of 30. T cosine of 30, this is t, and the force that is going upward is t cosine of 30. This is t cosine of 30, t cosine of 30. So this is the force going down, upwards. So because I have chosen to be upward to be negative, so it's minus t cosine of 30 due to this force, minus t cosine of 30 due to the other force. So the total force, the sum of all the forces is 0. So mg, how much is mg? The mass is 6 kilograms by 10 is 60. The external force is 410 going downwards. Minus t is minus t cosine of 30 plus minus t cosine of 30 minus 2t cosine of 30. So 2t cosine of 30 is 410. Here is the 410. So the t is 410 divided by 2 cosine of 30. So the force, the tension is, you calculate what is the tension. Okay, let's go to the next problem. The next problem say, in this picture, this is the mass M hanging is in equilibrium. The rope with this fastener with the rope with the wall is 38 newtons, and here there is another force of 59 newtons. 59 newtons going in this direction. 59 newtons going in this direction, and everything is equilibrium. It's in equilibrium. So we make again, and what is asking is what is the angle? This angle. How is possible that this is in equilibrium? It's possible because the sum of all the forces through the x direction is 0, and the sum of all the forces through the y direction is 0. So we have to place an equation that says that there is no acceleration in the x direction, and there is no acceleration in the y direction. So if we place this equation, the sum of all the forces in the x direction equals 0, so we see 38 going to the right. Let's say that I choose going to the right negative, so minus 38. Here there is 59 in this direction, but in the direction of the x direction, there is 59 cosine of theta. Because I have chosen the minus 38 to the right negative, I chose positive the 59 cosine of theta. So this is 59 cosine of theta. 59 cosine of theta is the length of this force, that is the component of the force of 59 in this direction. So from here, I can find cosine of theta, and from here, using your calculator, you can find theta. If you do the same equation for sine of theta, for the y direction, you will find 59 sine of theta minus mg equals 0. So you'll better not use this equation because you don't know what is the mass, m. So you use the first equation. Okay. So from this equation, you can now use the second equation to find the mass m, because you know now the theta. So you place the theta here, sine of theta, 59 sine of theta, that you know this number. You know how much is 59 sine of theta because you know theta. This is mg. So the mass that is hanging is this value, 59 sine of theta divided by g. So in this problem, they don't ask you about the mass, but this is the amount of mass that is hanging from the object. Okay, let's go to the next problem. The next problem is similar that the problem that we have done now. There is no equilibrium, there is acceleration, and the system is composed of three forces, of three masses, three objects, 9 kilograms, 4 kilograms, 6 kilograms. So we apply Newton's law to each object. So we take care that the tension here, the tension that is here is the same tension that is here. So we name this T1 and we name this T1. But the tension that is here is not the same one. The tension that is pulling the object to the 4 kilogram to downward is T2. And the force T2 is also the force that is pulling, the force T2 that is pulling the third object, the 6 kilogram going upward. I did a problem that when the rope have no mass, the tension here, T1, is the same as T1. Okay, so we do the problem. So how we do the problem? We say, what is the sum of the 9 kilogram? We pay attention to the 9 kilogram. We make a free body diagram, and we say, what is the net force acting on here? If the object is accelerating downwards, so 9g, the weight has to be bigger than the tension. So we choose now the positive direction as going downwards. So 9g going downwards, positive, minus T1, this is T1, equal N1A. So the equation will say these things. 9g minus t1 equal 9a. So we go now to the second object. The second object is the 4 kilogram, this one, and we make a free body diagram. We do the forces acting on the x direction. What is the forces acting on the x direction? I see T1 going positive, going up. We choose this positive direction, up. T1 is positive. T2 is negative, is the tension that the rope is doing on the 4 kilogram, T2. So, and there is the component of the weights in this direction, this is the weight, this is the weight, this is the weight, mg, and the component, as you know, is mg sine of theta. Mg sine of theta when theta is this angle, theta. This is the component of the weight in this direction that is a force that I have to take into account in the equation. So the equation says the sum of all the forces equal mass by acceleration. The sum of all the forces is T1 going up, M2G going downwards, T2 going downwards, that's why I'm putting negative sign, and M2A, A going upwards, that's why this is positive. So the first equation will be T1 minus 40, 4 by 10 is 40, sine of 30 minus T2 equal 4A. Now we go to do the same thing with the third object, free body diagram. What did say the free body diagram? Now over the 6 kilogram, there is a force going up and there is another force going downwards. And there is no more forces. There are no friction, nothing. So T2 going up, positive, minus M3G sine of theta going downwards, negative, equal M3A. So the equation third will be T3 minus 60 sine of 30 equals 6A. M3, 6A, A. I don't know A, I don't know T3, I don't know T2, I don't know T1. Wow, how many equations I have? 3 equations. How many unknowns I have? Because I did a mistake, this is T2. How many equations I have? 3 equations. How many unknowns I have? I have A as a known, T1 as a known, and T2 as a known. So I have 3 equations with 3 unknowns, so I can solve it. So how I will solve? So I will write the best way for me to solve it. There are many ways to solve these 3 equations with 3 unknowns. I will write the first equation, the second and the third. This is written here, the first, the second, and the third. So if I sum the first with the second, the T1 will disappear when I sum minus T1 plus T1. If I sum this with this, will appear this equation 9G minus T1 plus T1 will disappear, 0, minus 20 minus T2. If I sum on this other side, 9 by 4 is 13A. So 13A is the first equation. Now, the third equation is this one, is T2 minus 30 equals 6A. This is the third equation. What I will do, I will sum again. So 9G minus 20, the T2 will disappear, minus 30, equal, because I'm summing, 3 plus 6 is 19A. So this is the equation, so it will produce one single equation with one unknown, the A. And the A can be solved. 90, 9 by 10 is 90, minus 20, minus 30, everything is 40. 40 divided by 19 is around 2 meters per second square. Maybe it will not be the exact result because we have taken G equal 10 and you should take G equal 9.8. So when I do 9 by G equal 90, is 9 by 9.8. But I don't do it like this because it will take me more, it will make us more difficult calculation and it will be the same. Okay, so let's go to the last problem. The last problem say you have a pulley you have a pulley like this one, and it says these have the mass, let me read it again, 100 kilogram block is being released from rest at heights 1 meter. It takes 0.53 meters, it takes 0.53 seconds to reach the floor. So the time elapsed to perform 1 meter distance is 0.53. What is the mass of the block on the left? What is this mass? So if you arrange the system like this one with this pulley, and you perform and you say and you measure 0.53 seconds for the mass 100 kilograms to perform the distance of 1 meter. What is the mass little m that was hanging here? So this is how we will solve. We consider that the acceleration is constant. So if the acceleration is constant, the displacement delta y is 1/2 a delta t squared, because you remember that y is equal to y0 plus v0 y by t plus 1/2 a t squared. But in this case, I'm considering y minus y0 delta y, the change in y. The change in y is 1 meter. I consider v0y equals 0 because v0y is the initial velocity, and he say here that the velocity initial is from rest, it starts from rest. So delta y is 1/2 a by the time elapsed, delta t squared. So the acceleration is 2 times delta y divided by delta t, solving for a. Solving for a in this equation, this is the acceleration. So the acceleration will be like 8 meters per second squared if I didn't make the mistake. So now I will do the following thing. My goal is to find the little m. But to find the little m, the mass of little m, I need to know the tension here. I need to know this tension, the tension that is pulling little m. I might not need to know mg, so I don't know. But I know that the acceleration of little m is 8 meters per second squared, because the mass m is falling down at this acceleration. So what I will do, okay, let me go to the mass 100 kilogram, and let me apply Newton's law to the mass of 100 kilograms. So I would say the acceleration is going downwards. The value of the acceleration is like 8 meters per second squared. So there are more force going downwards than going upwards. So mg is bigger than t. So I will say, okay, the positive direction I will choose is always like the direction of the acceleration. So mg is going to be positive and t is going to be negative. So mg positive minus t equal ma. Mg 100 kilograms by 10, the g minus t equal mass 100 by 8. So it's 800. So the tension is 200. So I found this tension on little m, because on little m the tension is the same, pulling him up. So this is 200. So now I will apply Newton's law to the little m. So I will do three-body diagram for little m. The acceleration is going upwards, so the tension is positive. So T minus mg equal ma. T 200, m unknown, g 10, m by a, I don't know m. Let me correct these things. M by a, m by 8, the acceleration is 8 meters. So I made a mistake here. I don't know why I make a mistake. Let's go to erase everything. So it will be 200 minus mg, m by 10, equal m by a. So the 200 will be 8m plus 10m is 18m. So the m will be 200 divided by 18, and the result should be correct unless I made a mistake. Please check it and let me know.